All right, good morning, everyone. This is our morning algo session. We are going to introduce how to do a swap and how to use a temp variable to do that swap. Okay, so we have some code here, but I want to draw a little bit to show by analogy what I mean by swap. Okay, so imagine you have a cup full of water, put W for water, and you have a cup full of juice. You want the water to go in the juice cup, and you want the juice in the juice cup to go in the water cup. How would you switch the juices in the cup? Just logically, how would you swap out the liquids? Use another cup, right? We'd use another cup that's empty. Let's draw our third cup on the left here. This is our empty cup. E for empty. All right. If we dump our water into the empty cup, now our water cup is empty, right? If our water cup is now empty, and this empty cup has the blue water in it, we can now pour the juice into the water cup. So now we can do this. The water cup would then have the juice, and we can pour the formerly empty cup full of water into the juice cup. So we take the empty cup's water, we pour it in here, and now this, well, it should be blue. I made it yellow, but it comes from the yellow cup, it should be blue. So now we've swapped out the juices using a third cup that's empty. Okay. Let's do a pull check right away to make sure we're understanding this concept. How well, I know there's a little bit of a trick to it, but how well do we understand this concept of swapping? You have two containers that are full, right? If you want to switch the liquids in the container, you have to use a third cup and pour it into it. All right. I see that it's not all 10. So let's explain this again. I'm going to have to go through this until it makes sense. So you have one cup. Okay, you can't spill the water anywhere else. And you only have a third cup. Let's do it one more time. You need a third cup to put one of these contents into here. So this would be empty. Once this is empty, you can pour this juice into the water cup. And once this has water, you can pour this formerly empty cup into the juice cup. You've just swapped the juices, the liquids in the cups. So let's do that. Let's do that with variables. The reason why we're doing that with water and cups is because we're doing the same thing with variables. Okay? Look at this here. We have fruit 1 to be apples and fruit 2 to be oranges. If we make fruit 2 to equal fruit 1, what would happen if we console log fruit 2 and fruit 1? What's going to be the result? Someone type it in the chat. We get apples and apples. We wouldn't get a swap, right? Just like we see in the chat, apples and apples. Let's do a quick T diagram to demonstrate. So var, val, fruit 1, we have apples. Fruit 2, we have oranges. If fruit 2's value equals fruit 1's value, then we now have a new value for fruit 2. And so when we console log fruit 2 and fruit 1, we're getting apples and apples. So how can we swap? The same way we did the swap with the cups. Okay, so now we have a new T diagram. Okay, we have fruit 1. I'll just do F1. Apples. Fruit 2, oranges. Pretty normal so far. Now we have a temp variable. Temp variable equals fruit 1. What is fruit 1? Apples. So we say apples for temp. And then we say fruit 1 equals fruit 2. So now the new value for fruit 1 is going to be oranges. And then we say fruit 2 equals temp. So what is temp? Apples. So now fruit 1 is oranges and fruit 2 is apples. We've successfully done a swap. So when we console log this, we'll get fruit 2, okay, apples, and fruit 1, oranges. They have swapped their values using a temp variable. The first example does not work. Are you speaking about this one, Isaiah?
Yes, because when you show us that you wrote it that fruit 2 plus fruit 1 equals apple.
Yes, we want fruit 1 and fruit 2 to be swapped. We want fruit 1 to be oranges and fruit 2 to be apples. We want fruit 1 and fruit 2 to switch values. This is not the goal. We don't want apples and apples. We want apples. We want, what did we say? Fruit 2, apples and oranges, but we want them to be swapped values. We want fruit 1 to log oranges and fruit 2 to log apples. That's why we use the cup analogy, because a cup is like a variable. It's a container that holds something. But if you are holding something, you need to let go of that thing in order to open your hand to open something new. Okay. Okay, it's like that analogy of the monkey that reaches his hand inside of a tree to grab something and pull it out, but because his hand is closed, he can't pull his hand out. So you have to let go of what you're holding on to be able to switch values. All right, so temp has to receive that value as well. Temp receives fruit 1, and that's how you can swap. Use that temp to receive one of the values. Then you can say fruit 1 equals fruit 2 and fruit 2 equals temp.
This is kind of confusing because earlier we learned in the JavaScript, like when you have an array, the last one is the most important one. So if you had a fruit 1, then you declared fruit 2 to be the same, like fruit 1's apple and the fruit 2's apple, then the fruit no, let's say the fruit 1's apple, then you declare another fruit 1 orange, then the fruit 1 is equal to orange.
Right. Yeah.
So the last one.
And that's because they're using the same exact name. But in this case, we're using 2 different variable names. This is fruit 1 and fruit 2. We just want these containers to switch and swap values. Okay. So this is not reassigning the value to the same variable. We have 2 different variables and we're swapping values. In order to swap values in JavaScript, we need a temp variable to help us with that swap. Okay, so how is this going to help us solve algorithmic problems? How are we going to use this swap in order to solve our problems? Well, we have a problem that we're going to solve today in our breakout groups called reversing an array. It's the last problem that we're going to give out of the list of problems. And I want you guys to use the swap to reverse an array. Okay, so we have, let me draw an array really quick so we're reminded. So we have an array, let's say 4, 3, 2, 1, 0. Write a function that will return the same array, but reversed. 0, 1, 2, 3, and 4. Okay, return me the same exact array, but now reversed using the swap. Okay, that's not going to be the only thing we do today. We're going to go over week 1, days 4 algorithms as well. These shouldn't be too difficult. This should be just practice. The only new challenging thing that we are going to be working on, this one should be fine as well. Shouldn't be too difficult. The only challenging thing that we have today is using swap to solve this algorithm, reverse an array. So we're returning the same exact array that we've been given, but now instead of A, B, C, D, E, it should read E, D, C, B, A. Any questions?
Josh, this is a bit off topic, but this is about the algorithms course in general. I was under the impression that we were supposed to do that after we finish CSS, HTML, and JavaScript. So this.
No, we're doing this every morning. We're gonna.
Oh.
The topic of algorithms is going to be what we're doing throughout the boot camp for the first hour each morning, and then we switch to whatever we're learning for this stack. Okay.
Yeah. So this just came out of nowhere for me.
Okay. Yep, we'll continue to learn new things in regards to JavaScript. And so this is what we're learning today, the swap. Super important. I was able to secure myself a job once by knowing how to do the swap. So keep this in mind, it's super valuable. All right, let's break out into groups. I'm gonna go ahead and create them now. We'll drop in the rooms to make sure we're doing all right. We're not getting off course. And I'll pause the recording. Okay. All right. Welcome back, everyone. Let's go ahead and present our answers. I'll call on us randomly, assuming we'll volunteer right away. So let's go over each problem from first to last. Then let's T-diagram our answers, or show what we've T-diagrammed. So let's go over the first one. Starts with var x equals 5. Who would like to present for that?
I could present.
Okay.
Isaiah wants it.
Okay, can you share that T-gram? Okay, so first start out was x equals 5, variable x equals 5, and then it next is a console.log x, so the first number will be 5 in console.log 5. And then on the second one it says set x 15. So when you parameter the to the function.
Okay,
then,
we go here. Okay.
Right. And then x equals the new value. And now the x equals new value, which is x equals 15 now. Right.
Okay.
And then it's console log x. So since x is 15, and we need to console log x again, so it will be the 15. So the answer is 5 and 15.
Okay. All right. Does anyone have any questions? Okay, looks like we all got this one pretty well. All right, let's move on to the next one. Also starts off with var x equals 5.
I got it.
All right, Anthony.
Okay, let me share my screen real quick. Share screen, sorry. Share screen correctly? Yeah. That's weird. My monitors are backwards.
Okay, take your time.
Sorry, not it just I don't know what happened overnight. They flopped. Okay.
Okay.
So
Are you sharing? Because I don't think you pressed the share button yet.
nope, I did not. Now I'm sharing, correct?
Right.
There, in
Yeah.
2 seconds, it's loading. There it goes.
Mhm.
Okay. So where were we? So we start with our variable equaling 5. So variable x equals 5. Then we go to our function. We realize we don't do anything until we get to our console log x. So you get your 5 here. And then we go to result. So variable result equals add to -10. So we go to their function amount, or actually we go to our add to -10 function over here on our T diagram.
Mhm.
So amount is now -10, or sorry, then we're going to return x plus amount. So x minus, or 5 minus -10. 5 minus -10 is -5. So
So
we're going to return that.
on line 15, it's saying return x plus amount, right? So x is 5 plus
Yeah.
the amount we're
Which is
given.
-10.
Right. Okay.
So
So
that would
continue.
give,
Keep going.
so on line 15, we're going to do return x plus amount. So 5 plus -10 equals -5.
Right. Okay.
So that's our console log for result. And then we console log x again, because we didn't change x anywhere. It should be just 5.
Okay. Awesome. Okay. Well done. All right. Level 2 is cleared. Who wants to do the is palindrome function?
We can.
All right. Let's see it.
Okay, so we got a little bit of notes here. Get me 1 second. I'm just making it bigger so everyone can see a little easier. So for right now, I know usually we don't. Yeah, I think you had said you don't want us to have pseudo text too much when presenting. My only comparison here is I'll have the non-pseudo text version here.
Okay.
And then the pseudo text here.
Okay.
I always use the color comments to really break down each one each step of the way. So when we start with this function, you could see where function is stated. We look down, and the first thing we want to try and do is var result 1 is this array. I should probably make a little column here at the top that says result 1, the array value is those numbers, and then result 2 array is those numbers.
Mhm.
The way we broke it down was starting here at the top. You got left is 0. 0 is less than 5 divided by 2, or 5 halves, and plus, which then takes you down to the second portion of figuring out what variable right is. And that is going to be our length for that, which is 5, because right here we have 1, 2, 3, 4, 5 in the array. -1 equals 4 minus 0. Left is 0 right now. So currently var right is 4. Then we go down, we have array left, index left does not equal array index right. So right now we know that the index of left is 4, which is 0, 1, 2, 3, 4, which is the value 1, does not equal, and then we have array value right, and that value that was array value right is sorry, getting lost, which is also that equals 4. So sorry, 0, 1, 2, 3, 4, which is this value, which is 1. Those don't equal each other. So we spit back up, go through the whole process again, but with 1 this time, because we're incrementing by 1. This eventually gets us down that same path where 1 does not equal 2. So then we now know this is not a palindrome. We see down here to console log the result, which is not a palindrome. We console log that result here. And then we go back through the same process over again, but now our result 2 is the topic that's being, the array is being called on, and our array length is now 6. So it's a similar breakdown, 0 minus 3, because you have 6 divided by 2, so you can just do a whole number here. Break it down, the variable right becomes 5 as the index that gets called on. Our left is currently 0. That 0 spot is 3. So we have 3, and the index spot of 5 is also 3. You end up with 3 does not equal 3. So you kind of go back up again, except this time with 1, breaks down 2 does not equal 2. Then it comes back up to 2, and that breaks down, and those indexes become 1 does not equal 1, and then 3 is not less than 3. So you skip out of this. So then you skip out of this, and it is a palindrome. And we return palindrome, and down here, and it says console log result 2 palindrome, which gives us final answer of console logging, not a palindrome, comma palindrome.
Okay.
Hopefully that's right.
Yep.
Cool.
Let me just keep your screen here. Let me just point out some things about this algorithm before we move on to the next one. All right. So a palindrome is a word that's spelled the same way backwards as it is forward. Why then, when we're iterating through an array that we're checking if it is a palindrome, when we have a function like this, why do we stop at array.length minus 2? Why do we stop there? Why is that our endpoint?
Because since you're comparing the first half to the second half, so if you do that, you don't need to go back and compare it flipped again, because you just compared both halves to each other.
Right. Yeah, that's because at the very center of the palindrome, you should see the left side mirroring the right side. So you don't need to check the entire array. You just need to check half of it. If the left half is equal to the way you read the right half, then it is a palindrome. That's why you only need to stop halfway through. You don't need to read the whole entire array to check if it's a palindrome. You only need to check a half of it to compare to the half that you're reading. All right, one more thing here. We have this var right. Let's see how this works. So left initially points at, I'm looking at this array at the bottom. Left originally points at this array all the way to the left, right? That's my L. It's kind of uneven. All right, there's my left pointer. And then I have my right pointer, and its value is array.length minus 1. So that's how we get the very last value, minus left. What does minus left do? Well, as left increases in value, you subtract more and more from r.length minus 1 to be right. So as left increases, and as it increases, left goes more towards the right. As left increases, we subtract that amount from right, and right decreases and moves over to the left in our array. That's how we're able to check both positions at once. We're checking left against right. As we move left, we also move right, and if we get to the center, we stop. Okay, does that make sense to everyone? Anyone have any questions about how this algorithm works? Not just T-diagramming it to get its values, but how a palindrome check works.
Can you go over the last part again? I think you mentioned. Yeah.
All right. Let me just share my. So you have 0, 1.
Here, do you want me to stop sharing?
Oh yeah.
There you go.
Sorry, I assumed I was sharing for a second. Forgot it was not my screen. So you have an array here, 0, 1, Oh, doesn't matter the order. 0. Yes, it does. It's a palindrome. Okay. So 1, 2, 3, 2, 1. This is a palindrome, right? Okay, so we have our left pointing here, and it's just the array at position 0. So R at 0. This here, this right pointer, is R at R dot length minus 1 minus left. Minus 1 minus left. So when R is 0, is it? Oh, now I'm having doubts. Let me check the platform. Sorry, I lost my train of thought there. Okay, so we were on palindrome check. Let me check here. So we're checking if the value at R dot length is not equal to R dot right, right? So that's where we're checking the values inside. Var right is equal to R dot length minus 1 minus left. So as left increases, if left shifts to the value of 1, then right equals R dot length minus 1 minus 1. So R dot length minus 1 minus 1 would be at this position, all right? If left increases to 2, R dot length minus 1 minus 2. So minus 1 minus 2 is minus R dot length minus 3, right? So where's R dot length minus 3? It's here. Oh, my arrow. It's at the 1. So this is a nice way of making a right pointer to decrease to the left as the left pointer increases. So you can check values on the beginning of the array and the end of the array at the same time. I just wanted to point out, this is probably the first time we've run into something like this, but this is a cool way to move your right pointer from right to left as the left pointer moves from left to right. And then you just compare the values. If they're not equal to each other at any point, we just return not a palindrome. If at any point, if we get to the very end of the middle, which is the middle of the array, then we return palindrome. Okay, that's all I wanted to show. In case we didn't, if we just T-diagrammed and didn't understand what was going on.
Thank you.
Okay. All right, thank you guys. All right, last one. Who wants to present for the very last one here?
Isn't there 2 left?
Isn't there 2? Is there 2? Oh yes, there's one that's a while loop. That one's not so hard. So let's present for the while loop and then the very last one here. Who wants to present? Okay, I'm gonna pick on a group. Aaron's group. Can you present for that one?
Yeah. So I think Aaron's in the bathroom, but I'm in his group, so let me just hop over, share screen. So it was for problem 4, right?
Yeah, they're not numbered, but it's the second to last.
Yeah, sorry, I don't have this up in my VS Code, so I'll just look at the T diagram for it while I look at it on here. So we have a variable start equal to 0, and then we have variable end, which is equal to 12, and they'll change in increments of 2. And our while statement is declaring that while start is less than end, we're going to console log start plus the start value and end as well as the end value. And those increments of 2, we're going to print it out 3 times because once start and end value are equal to 6, start is no longer going to be less than end. So we would just get a console log of start 0 and 12, start 2 and 10, start 4 and 8.
Okay. Yep. It looks like you're correct, but it's a little hard to follow along when we don't see the actual code.
Yeah, sorry, Aaron, he has the code.
Okay. Okay.
Sorry, I had to go to the bathroom real quick.
Here.
Okay. All right. No worries. Let's just move along. All right. The very last one here. Let's see who wrote the function for reversing an array.
We actually wrote it, but we didn't T-diagram it, so I don't know if that's going to be a
Okay,
problem.
that's fine. Let's just see what you got.
Edward, can you throw up your actually here? It's fine. I forgot that we didn't write it, so we didn't write the. Okay. Okay. So here's the function. Oh. So I wrote function reversed array with the parameter of array, and then like you described with the 3 like the 3 cups. So I created a empty array,
Mm-hmm.
and then I created a variable called I, and I set it to array.length -1.
Mm-hmm.
And then if I is greater or equals to 0, I push the array. So it starts from the bottom, from the very end, and it starts pushing this one basically. Then it's going to go back up. It's going to minus, so it's going to take away from. So it's going to go from here to here. It's going to push this. Then it's going to push this, and basically runs through it and reverses the whole array.
Okay. Okay. So
sorry, no T-diagram. We were like, we were cut off halfway through. As
no
you...
worries. So let me point out something here.
Yeah, go ahead.
In this solution on line 53, we created a variable where we're pushing all of our values that we read into that array, right? We're just starting backwards and we're pushing it as we read it backwards, right?
Yep.
So this is one way to solve it, and we create a variable that holds the memory of the whole array.
Yes.
When we solve for algos in the future, and this is totally valid way of doing it, but when we solve for algos in the future, we're going to want to optimize our code so that we use as little memory as possible, and we're using as little function steps as possible. So that's going to be the number of steps our algo takes to solve it. And there's nothing wrong with the number of steps, and it's totally fine. But what I was looking for, and it's not saying that you did it wrong, but what I was looking for is to swap the values using a temp variable. So for every time you
okay,
go
I
through
know what
something
you
in the
mean.
array.
Yeah, so basically push it into a temp variable and then rename that variable, like and then add the value of the just say reversed. So like, let's say this would be my temp, right?
Let's do it together now. Let's on line 55. Let's comment out line 55. I don't want to delete your code. Let's just comment it out.
Yep.
Okay. Then let's indent below it. Okay. Let's say var temp. Let's make it hold the first value in that we read. So it can be var temp equals what we read at I, right? Var temp can equal I.
So just equal I.
Yeah. So I would be whatever we're iterating through at that moment. So in this case, it's going to be the very last value.
Mm-hmm.
All right. And then below, let's indent one more time. And we're going to say r dot length minus 1
Oh, sorry. Length -1.
we're going to make that to equal the value at 0.
So the value, so it'd be
Yeah, so r at 0.
oh.
All right. And then let's indent again. What's wrong with that equal sign? What did we do wrong there?
You're saying 4 equals
Oh,
array at 0. Oh, no, you need to wrap array.length -1 with array bracket.
So we want to say r at r dot length minus 1. So r dot length minus 1 should be in the bracket.
so
It should be, I'm putting it in the chat right now.
sorry. This is.
Oh, no, yeah,
I don't
misspelled
know.
it. Nick has
I
it.
don't
Yeah, Nicholas has it.
Oh, okay.
Forgot. Yeah.
So it'd be, and then, so it'd be here, right?
Yeah.
So R, and
And
then this,
then
this would be in this, oh, sorry. Oh, God.
There we go. Okay. So now
then-
r at r dot length minus 1 equals the first value. And so what do we want to make the first value equal? Or sorry, I asked the wrong question. What's the next step? Let's ask that.
So if R at length -1, so we're starting at the bottom, at the end is equals to the first one,
Mm-hmm.
the first. I'm sorry, I'm so lost at this point.
It's okay. Let's indent
Yeah.
and we'll complete it together. R at 0
Log it.
So R at 0
equals
equals, and then
you know what, I think it should be r at I. Yeah.
oh, okay.
No,
Is it
r
for-
at 0 r at 0 equals r at I.
Oh, R at 0 equals R at I.
Yeah, and 56 should be temp equals r at I. 56 should be
56
bar
temp
temp equals r at I.
R at I.
And that's how we do the swap in place. So
Okay.
as we iterate through our array, oh no, I'm sorry. 58 should be r at 0 equals temp. Excuse me. Yeah.
Oh, okay.
That's what we're doing.
Temp.
Shouldn't
Okay.
R at 0 also be R of I?
R at 0 should be also r at I.
Here,
Because we want to be
moving it, right?
Yeah,
So
that's
it'd
always
be-
going to be at index
Yeah,
0.
right. Yes.
And then here.
Okay, because yeah, I was gonna say, that's one thing that confused me, because I was like, if that's a 0, that's always gonna check again. It's always gonna change it to 0. To the,
Well, no,
to the
we
index
start at
0.
r dot length minus 1, right? So
Yeah. But if it equals this every time at array at the location of 0, which is the first, so it always be, yeah, so this is the right way, right? With
Mm,
I.
hold on, Vincent, because right now, help me figure this out, I guess, because we're starting at the very end, right? R dot length minus 1. So we're saying temp equals r at I. We're saying temp equals r at r dot length minus 1. So let's T diagram this now that we're in the rough. Okay. So let me do the text.
I would, so normally you would start at the beginning and work the other way, but since we're starting backwards, you should probably set temp equal to the very last one. Because
Okay,
what?
so it'd be array and then dot array, and then array dot length -1.
Yeah. So temp will be holding E in the very line 56.
So basically all this right here will be in here. It's the same thing.
It just,
Yeah. Yeah, let's swap it out. Yeah.
And then just paste it over array bracket I, not inside the bracket. Yeah.
Yeah, I got it.
And then now the very end is equal to the very beginning. So now array of I, array of I, which is, oh no.
Line 57, R at I should be R at 0. So we're giving the very last value, the value at the very beginning, right?
Yeah. Doing it backwards confuses me a lot.
Okay.
Yeah.
And then we say R at 0 equals temp.
Okay. Is there anything else I need to change? I'm more confused now than I ever was.
No, it's because we ourselves got confused because you read through the array backwards, so we don't usually have to do the
Okay.
swap backwards, and that's
okay.
why we got tripped up. So
Okay.
let's just T-diagram this out, end this session, and then move on to the next, because we're going well over the hour now. Okay,
sorry about that.
It's okay. It's not anyone's fault. All right, we have temp. What is R dot length -1 in line 63? Temp equals R at R dot length -1. That's E, right?
E, yeah.
Yep.
Sure.
So temp equals E, and R at R dot length -1. So this value here, we're making it to R at 0. So now that's going to equal A. So you can even switch it out on line 63. So you can switch out E to equal A.
So this will be A.
Yep.
And will it swap together?
And then the last line, line 58, we're going to say R at 0 equals temp. Okay. And what is temp is E. So R at 0 equals E.
Okay. So it's just going to swap them out as
Yes.
it iterates through.
Yes.
And loops through it. Okay.
Yes. As
so
it
it's gonna,
through.
so basically takes this one, puts it in temp, right? Holds it in temp for a little bit. Then it swaps it out for B. Then it takes this guy and drops it down to here.
Yeah. Temp just holds that value so that the swap can happen.
And then because C is in the middle, it just doesn't.
And
move.
hold on a second. So now we can edit our for loop to make it to be right in the middle, right? So R dot length. So we say, well, I is greater than 0 or R dot length divided by 2.
So
I should stop at the halfway through the array. So how did we say we did that in our palindrome?
So it's divided by 2. So it's it would be
well, no, it's okay. Well, I is greater than R dot length divided by 2.
Oh, okay, not minus. Wait. So it's I is greater. I equals R dot length -1, right? That stays the same.
So that stays the same. We want to stop at halfway through the array. So how do we stop at halfway through the array?
It's divided by, so we would take R dot length divided by 2.
Yes. So write that out.
So R.
And you know what? We can devote more time to this tomorrow morning. So so we also want to say, well, I is greater than or less than R dot length divided by 2.
Oh, okay. So if I is greater or less than?
Greater than or equal to?
Or equal to, yeah. Does that look correct?
Yes.
Okay.
Vincent, you're saying something wrong here in the chat?
I think it just goes back to
because
that array of 0 is always being set. Like E is always being set to.
So this should be I.
No, because I is the very
it just
end.
keeps iterating through.
Okay. Since this was the one at the very end and this was the most difficult one, we'll revisit this tomorrow. We'll perfect our understanding of this. I wanted to challenge you guys and push you to day 5 content. So if it was too difficult to understand, we'll revisit it and we're still on track as far as understanding our algos, okay?
Okay.
But right now we have to break up because we have to make some time for our next lecture. Okay, so I'll stop the recording. Does anyone have any questions besides that one?
Yeah, were we supposed to be on day 5 today?
No, what it is that you guys did programming basics, so you're ahead of the curve at than you would be if you didn't. Okay, so that's why I'm seeing how far you guys can go as far as challenges. Okay, so we'll revisit again tomorrow. I'll stop the recording now.